Well, hello everybody. Happy Friday. Hope you are doing well. Uh, Yesterday, Mrs. Aguilar told me that you guys didn't get to everything because you had some cut class time because of advisory. So she has some new plans that she is going to be doing instead of what we had previously planned to do. So be very patient, very considerate, and use this time that you have extremely wisely and make sure you follow her directions. Okay? Same rules apply. Keep that in mind. I've said it for 3 days now. I think we're good. So I'm going to go ahead and get started. You have a quiz today. I told you that on Tuesday. And we're going to do a very quick review on it. I know you're thinking, why do we have to review if we are using our notes? You still are going to review to help you get through this a little easier. I haven't gotten any questions via phone or email, so I'm assuming that you guys are understanding the information. If not, that is your responsibility to make sure that you ask any questions as necessary. So I'm going to try to wrap up this review in about 10 to 15 minutes, and then you can go ahead and go on about your day. We will not grade these until most likely I get back. Alright, this is a cute little map of North and South Carolina. I think someone in second period helped me find this one. So we're talking about your river basins. And one of your questions when we went over this last week is, which river basins appear to flow into South Carolina? And that appear word could have been interpreted differently. But if you look at what you have right now, looking at the map, you will see that your North Carolina River, North Carolina is outlined. Remember, north, which means up, is Virginia. South is South Carolina. To the east of North Carolina, we have the ocean. And to the west of North Carolina, we have the mountains. Notice that one of the other things we talked about is there are more river basins on the western side of North Carolina, mainly due to the mountains and the overflow of that. Alright, so looking at this, here we go. We see that we currently live in the Catawba river basin, and that appears to be the yellowish color kind of in the middle in that shorter part. Catawba River Basin flows into South Carolina. There was that question, why can South Carolina sue North Carolina for pollution? Because our river basins, the river basin technically starts in North Carolina, so when something flows down, it'll flow into South Carolina. So Catawba is one we share with South Carolina, but it is also the one we live in. Then you'll see the Hiawassee is still one of the smaller ones, and also barely touching into it, Little Tennessee, and Broad, and Yadkin PD, and some of the ones on the east side also flow into South Carolina as well. So remember your river basins. Alright, so I know this water vapor slide may be just a tiny bit harder to see than you want, but you've seen the same one since 5th grade, so I don't see why you would have too much problem understanding as we go through. So right underneath the sun, you see condensation. But underneath that condensation is evaporation. So how does evaporation occur? Now remember what we said earlier this week, that water is the only thing we find in nature in all three forms, liquid, solid, and gas, so all three states of matter. So evaporation happens when water is heated, and the heated water goes from a liquid, and now it goes to a vapor. Okay, so it went from a liquid to a gas, and that's evaporation. Now what about transpiration? Transpiration is the water in the trees get heated, move up. That's the term I want to use. I think we're going to go with that. Go from the liquid to a gas. So that's transpiration. Keep in mind, TR, trees, transpiration. So evaporation and transpiration occur due to heating as they rise up into the atmosphere. Because remember, they're less dense, so the gas is going to rise. And they're warm, so that contributes to them. So they go up, and condensation occurs. So that's when all your water vapors start to get closer together. Okay, so it's cooling down a little bit, it's getting close together. That's what clouds are. Okay, clouds are not cotton balls. Clouds are water vapors that are stuck together. I think we use or that are condensed together. Sorry, the activity we used was on a penny. So how many drops of water can fit on a penny to talk about the cohesion of water molecules. Precipitation, remember, is anything. So after the heating and the cooling, precipitation is happening. And what precipitation can be: sleet, hail, rain, snow, any of that. So as precipitation falls down to the ground, and whatever form it chooses to fall down into, two things will happen with precipitation. Okay, it'll either become runoff or it'll infiltrate. Okay, so remember, runoff literally runs off the land, and it's running off the land into another body of water. So as you can see in this case, it's running off the mountainside and it's going into what I believe to be, the ocean. Wanted to make sure that was probably. Then it can also infiltrate. And remember, infiltration is when it breaks through the barrier of the ground. Okay? Yes, it breaks through the barrier of the ground and then becomes groundwater. So soaks in, becomes groundwater, and groundwater is where our water is stored. Okay? Water stored underneath the ground. All right, so continuing on, speaking of infiltration and runoff, what's happening underneath? So what's happening with the groundwater? Well, as you see, there is that zone of saturation that currently is the part completely covered in water, which is represented by blue. And then you have your zone of aeration right underneath your tree there. Now the zone of saturation is where we talked about it's completely soaked. Okay, being caught in the rain, you're completely soaked through and through. Nothing else is getting in there. The only thing filling that space right now is soil and water. And that's what's really filling that space. Now the zone of aeration is going to be your area where there's not that water that's being stored. I hate to say it that way, but let's think of it that way. There's no water that's being settled there. Okay, so it is filled with. It's an area with air and soil, more of that than anything. So what separates the zone of aeration from the zone of saturation? That is your water table. Okay, so keep that in mind. That's pretty much how high the water is, the groundwater is at that point. So if you have a water table, what do you think? If you have a low water table, that means that there is going to be a larger zone of aeration. Okay, so think about that water table, thinking about where it is in your picture right now. Think about if it was lower. Think about your water table. The word water table was all the way down to your zone of saturation. It's sitting right on top of it. That means that entire area above it, okay, would be the zone of aeration. So now you have a longer zone of aeration and a smaller zone of saturation. So if you have that longer zone of aeration, that means that there's nothing but it's nothing but air and soil filling that space right now. That means there's a good bit of room for water. So the lower your water table, the less likely for flooding. The higher the water table, the more likely it is for flooding. Because there's not places for the water to go. Not guaranteed, but most likely flooding. So notice also over you have right in the middle, you have your well. Now remember, your well is dug deeper than the water table to ensure that you have water. And the way that water gets sucked in, it develops this what they call cone of depression. All right, porosity and permeability. So remember, porosity is the amount of pore space, okay, in between the soils. So as you look at figure 1, there's actually a good deal of pore space in between those. And permeability is the second thing, okay? And this is the ability of water to percolate or flow through. So after it's infiltrated, the ability for it to flow through the soil. So note at the bottom it says the higher the porosity, the higher the permeability. So the higher the amount of pore spaces, that means that empty space in between, the higher that is, the more it's going to let water through. Okay, so it's permeability. Now let's take a look at another one, an example. Now the example we have right now is one where we watch the virtual lab. The first one is gravel, the second one is sand, then you have silt and clay. Okay, so I want you to look at the permeability of that. Notice that it took 2 minutes for water to flow through gravel, 20 minutes to flow through sand, 2 hours to percolate through silt, and 2 days to go through clay. So if the pore spaces, again, if the pore spaces are tighter, then it's going to be harder for water to get through. So a low permeability, low porosity, which means it doesn't have a lot of pore space, is going to equal a low permeability, most likely. Alright, so we're looking at the Coriolis effect. Again, we're going to have to go through this. It's very important that you understand the Coriolis effect because it drives not only the oceans but also the weather. So with Coriolis effect, looking at this, particularly looking at the diagram and picture in front of you, you see red and blue. So keep in mind, what do your red and blue stand for? Your cool water, your warm water. What do you notice about the line in red? What are they closer to? Okay, hopefully you figure the equator. And what are your blue lines on occasion closer to? Okay, hopefully you said the poles. So notice how it's going in a convective flow. Just like in the lithosphere, remember that convective flow? It's the same thing here. So you must understand convection in order to understand the lithosphere, the hydrosphere, and the atmosphere especially. So looking at this, warm water, look at where your equator is, and look at where your arrows are. That warm water, if water is coming from the equator, it's going to be warm. If water is flowing from the North Pole or South Pole, it's going to be cool. And that's why I wanted to pick this one to show you exactly how that's going to be. Even if you look at the southern hemisphere, notice that the arrows are going in a different direction than they're going in the northern hemisphere. And that's okay. That's part of the Coriolis effect, so that's fine. But notice no matter what direction those arrows go in, your warm water is always going to be closer to the equator. Alright guys, well that's about 13 minutes of review. Hopefully you paid attention and you're going to do well on this quiz. So go ahead, knock it out, knock them dead, write on a separate sheet of paper and not on my quiz. Okay? Alright, I'll see you soon.